Assalamu alaikum. Good morning, everyone.
وعليكم السلام ورحمة الله.
Okay, so
وعليكم السلام دكتور.
الحمد لله على السلامة.
alhamdulillah, السلام الجميع, inshallah. Thank you. Okay, let me start. I appreciate your presence today with us. As we have been doing it since 3 years, we're going to celebrate today the Asteroid Day, June 30, and we have a very rich program. I am hearing some background noise. If you can please mute your system. Thank you very much. So we have very rich program, as you can see on your screen, and hopefully you're going to benefit a lot from it. I will not talk about it. I will talk about the end of my presentation. So we are the Sharjah Academy for Astronomy, Space Science and Technology. We are a research institution plus a public outreach institution plus an academic institution. So we have 3 units. The academic unit where we have the MSc in Astronomy and Space Sciences. We also host the MSc in GIS Remote Sensing, and hopefully in the near future, we're going to host the MSc in Aerospace Engineering. And we have the public outreach program with its nice planetarium and so many space exhibitions, and also the research laboratory unit with so many research labs. And I believe if you if you would like to visit us to know more about us, visit our website. It's very simple, www.saasst.ee, and you get more what you need. Okay, Asteroid Day, June 30. So why do we have to celebrate this? This is just a nice picture showing a typical asteroid. This is asteroid Ida. It has even a small moon, so it was able to catch something productive. And look at the size of this stone. Look at the size, about 60 kilometers by 25 by 18, meaning that it is not like a planet, spherical. Why? Because these bodies do not have enough mass for gravity to play its role. What kind of role does gravity have? Well, gravity is what we call has this kind of spherical symmetry. If you have enough mass, it will form spherical bodies like stars, like planets, like big moons, and so on. But these asteroids, most of them are in between the orbit of Mars and Jupiter. We have millions of them there. The largest one about 1,000, the smallest maybe a couple of meters. And they are there. Some people may ask why they are there. Well, we had an old theory saying that maybe a planet exploded there, and that's why we have all of these millions of debris, but planets do not explode there by themselves. They don't have enough energy. So these are just the leftover of the solar nebula that form the sun and the planets. I won't go beyond that. So this is it. So let me just talk about my content. The Tunguska event, June 30, 1908. What was it? A story behind the Asteroid Day, objectives of the Asteroid Day. How can we achieve these objectives, and also what we have done as a celebration in 2018, 19, 2020, and also what we are doing today. So, Tunguska. So you see on this map what you call the Russia as it is now. So in 1908, something happened around this city, Tunguska. It was like an empty location, a lot of trees and so on. Look at the location of Moscow. For those who know history, 1908, just before the beginning of World War I, there was some kind of turmoil in the Soviet Union. So the beginning of what you call the Soviet Union revolution, the Communist Party and so on. So there were a lot of troubles there. That's why this event that happened in June 30, 1908, passed almost unobserved. So what was it? Well, an explosion happened that decimated a very big area, about 2,150 kilometers square. More than 80 million trees were burned. It was classified as an impact event, even though no impact craters were found. The object is said to have been disintegrated at about 5 to 10 kilometers above the surface, and the stone responsible for it, this meteoroid, the size 50 to 190 meters. This is just estimation because we never found the aftermath of this event. So look at the location. Even after more than 100 years, we have this empty space just as a fingerprint of what happened June 30, 1908. So a large area, 2,000 kilometers squared. It is quite a large area. As I say, this event went unobserved because people were not. This area also is a little bit desertic, so no big cities around. That's why no one take care of it until later on. So, what's the story behind the Asteroid Day? Well, in 2016, the United Nations proclaimed June 30 of every year to be a day of celebration. Not to celebrate that something fell upon our heads and be happy about it because it may mark the end of civilization, but just to remind us of something that may pose a threat to Earth. So in 2016, after some lobbying done by the celebrity, the scientist Stephen Hawking, I believe every one of you knows about him, and also the filmmaker Gregory Richter, which we did invite in 2018 here at the Academy to talk about this Asteroid Day. So these two co-founders, they did lobby a lot at the United Nations to have this day being celebrated. And for sure, a bunch of scientists, astronauts, artists also signed this Asteroid Day declaration. So since 2016, it has been a day set to remember us of what happened during June 30, 1908, and what kind of threat it does pose to civilization, to planet Earth as a whole, because Earth has seen so many impacts before. I believe some of you may know that we attribute the end of the dinosaur era to something that fell on Earth 65 million years ago, and so on. And because of that, so we have no dinosaur today. So these threats, they do happen. So what are the objectives of the Asteroid Day? Is to raise public awareness about the asteroid impact hazard. It is a big hazard, yes. Well, we see impacts every day. We have what you call these meteors that do strike our atmosphere. We see them from time to time. And at the end of this workshop, we're going to talk about what we have here at the Academy in terms of the UAE Meteor Monitoring Network, and talk about what we do as observation. So we need to save Earth from asteroids. But before we save Earth from the asteroids, we need to discover them first. We need to increase the rate of discovery of these asteroids. Now we may discover maybe around thousands each year, but we'd like to reach at least 100,000. Why is it difficult to observe them? Because some of them are small and they are undetected. So it will take a lot of resources, a lot of maybe space telescopes to observe all of this. That's why it is not an easy task. Just to give you here, this is Asteroid Ceres, one of the largest one, but 940 kilometers. Look at the size; it is almost spherical. And the image to the right is telling us, are we prepared for such an impact? For sure, you may have seen so many movies, Deep Impact, Armageddon, and so on. So all of this may be true in the near future. So how can we achieve the goals of Asteroid Day? Well, we need to use new technologies to track this near-Earth asteroid, and one of us is going to talk about it. We need to increase the rate of discoveries by at least 100-fold, And also we need to adopt this worldwide. So meaning it must not be only one single country responsible for this observation, because it is an Earth problem. Everyone is concerned by this. Let me show you this video here that you're going to see just the number of asteroids that we have around. This is up to about January 31st, 2018. You can see that we have a lot, and for sure, the list is increasing, and at some time it will be quite very, very dangerous even to send a rocket into space. This is as January 2009. Look how this map is being populated. So whenever we discover, we put it on this nice video. Look at the number, how it is increasing. So these are what you call the debris. Some of them are natural debris, like this asteroid, and some of them are artificial, like maybe the leftover of rockets, of boosters, of dead satellites. So we live in this jungle of everything. That's why we need to be a little bit responsible. So as I said, we have been celebrating this since 2018. So this is our first celebration. So every time we do a lot of so many lectures just to initiate the general public, the student, to this problem, and also our government, that this is a real threat to civilization. It is not just asteroid and that's it, we talk about it one day and next day we forget about it. This is the celebration 2019, so our academy was open to students, alhamdulillah. 2020 we did it, but it was closed because of the pandemic situation. So for today, so we have this rich program. I almost finished with my short presentation. So we have 7 lectures. The first one will Dr. Bashar will present what we do here at the academy in terms of all of its units. We have a special lecture about space debris, then another one near Earth objects, another lecture to talk about what we have as meteorite collection. You may know that we have one of the richest meteorite collection in the world, more than 10,000 stones from different parts of the world. Lecture 5 is this UMMN, about observing meteors, and the last lecture will be about the SAASST asteroids discoveries. We have an observatory, an optical observatory, and it is observing and also discovering these small towns. So this is my presentation for this workshop, and I would like to ask the next lecturer, Dr. Mubashir, to take over and to share his screen with you. Thank you very much. I will be back at the end of the workshop. Dr. Mubashir, you can share your screen.
Sorry, now I can do it. Now I have I did not unmuted myself. So
okay, so go ahead.
It's clear now, yes.
Yes, I see your first slide. Yes.
Okay. Assalamu alaikum. I'm Dr. Mubashir. I'm working at this academy since 2016, and this is the first time that I've been given responsibility to present. Normally, Dr. Ilyas used to do it, but let's see if I can do it this time and how. So let's start with the outlook. Since I have only 15 minutes, so I will go a little bit not faster, but quicker. If any questions arise, please let me know, and I will be happy to answer. So we have these 5 observatories, 2 observatories and 5 labs, and I would consider that we have sometimes 4 labs and 3 observatories, because one of them is Radio Astronomy Lab, which can be considered an observatory because of its 2 telescopes. So we have a CubeSat lab, we have Meteorite Center, we have Space Weather Lab, we have Radio Astronomy Lab or Observatory, how you call it, and High Energy Astrophysics Lab. Then we have 2 observatories, Sharjah Optical Observatory and Lunar Impact Observatory. So I will go through the lab, the 5 labs, which I will talk about it. For observatory, later on we have a lecture from Mr. Tanafa. Before I go on to talk about different observatories, or different labs, I would like to give you an overview of what instruments do we have in SAASST. So we have our meteorite monitoring network around the UAE. It's comprising of 3 towers at the moment, but this network is expanding. This network is used to observe the nighttime passage of all meteorite over the UAE sky, or as far as we can see. These towers are strategically located to cover the whole UAE sky, and I'll talk about it later. And then once we observe it, we have to understand whether we see is a meteorite or not. So we use the meteorite machine learning center to understand whether we see it through different simulations and different software to post-process the data from the towers. Then finally, once we are a little bit sure about some of the stones which are meteorite, we send it to Meteorite Analysis Center, where they are physically and chemically analyzed for final decision on whether we have a meteorite or meteorome, you can say, which is not a meteorite, a normal stone. Other facilities at SAASST include 2 of the radio telescopes. One of them is Decometric telescope, which is present on the premises of SAASST. I'm gonna give a brief on this one as well. And a 40-meter radio interferometer, which is comprising of 3 5-meter dishes, comprising to make a full interferometer of 40 meter. Also works in a radio frequency. We have another facility as a CubeSat tracking station. This tracking station works in VHF, UHF frequency, and apart from this is basically prepared for our own CubeSat, which is going to be launched next year, inshallah. And apart from that, it can be generally used for tracking other satellites, which are freely available for tracking and use of data. Finally, we have 2 instruments under Space Weather Lab. These instruments include the ionospheric radar system, which is normally known as IONOSON, and it is used to monitor the changes of space weather effects on the upper atmosphere. The other instrument is rather a multi-dimensional instrument, which is a global navigation satellite system receiving station. It is a highly capable station which also detects the scintillation, the upper atmosphere disturbances on the radio signals by receiving them and analyzing them through various ways. Apart from receiving the GNSS data, it also detects many other factors that can be present due to the space weather effects. So if I jump on these lab one by one very quickly, let me talk about first the Meteorite Center we have. It has 3 main sections. The main one of the sections is the network of these towers, which is installed throughout UAE for the detection of the passing meteors. Then obviously we have a machine learning unit which analyzes the initial data for further processing, and finally the Meteor Analysis Center, which can finally confirm whether we have a meteor or not. So in Meteor Monitoring Network, if I go further, these are the 3 locations along UAE. We have one here at the premises of SAASST. We have the other 2 are in the deserts of Al Yahr and Liba. And you can see the GIF above is one of the deserted location which can detect a meteor passing by. Basically, all of these towers are equipped with 17 cameras, visual cameras on each of them, and they work in the night sky and the black background of night to detect the passing meteors, as you can see in the GIF above. The towers are really like structure, and they cover 360 degrees of the sky. The aim, obviously, to find out every passing object which is passing in the night sky. So they may be meteor, they may not be meteors, and how we detect them, how we separate them is by our machine learning unit. After capturing all the videos throughout the night, we have to post-process the data. So basically, we do in 2 ways. If we have a stone and we need to understand whether it may be a meteor or not before processing it further for physical and chemical processing, we go to meteorite recognition, And there we take a picture of the meteor, and then we apply machine learning algorithms to see if it is a meteor or not. And how we do it, we make our machines learn through Meteor, SAASST, vast meteor collection, which we have here at SAASST. And also we randomly collect rocks to make our machines learn about stones and meteors. For the videos we capture throughout the night through our towers, we try to classify images according to how they are look like, and then we need to understand whether the passing object was a meteor or any other thing, metal thing like an aeroplane or any other thing. Since we only use visual means, we need to post-process this data carefully to differentiate between the real meteors and the objects which are not meteors. Finally, if we have some objects available on ground, we collect them, or somebody brings us some object to test as a meteor or not. We go to the meteorite analysis unit. It has, they analyze samples using primary tests such as streak and magnet tests. They have a range of equipment to physically and chemically check all the rocks, and they differentiate between the meteorite and terrestrial rocks. We also are collaborating strongly with the Advanced Material Lab in Department of Applied Physics and Astronomy at the University of Sharjah, and using their equipment such as XRF and XRD to finally detect whether we are testing a meteor or not. So this is a very active center at SAASST, and throughout the year we have different activities in this center at different levels of processing. Moving on, we have a CubeSat lab, which is currently very active because we are preparing for our designed CubeSat, which is in the final stage of completion and going to be launched hopefully next year. But apart from the CubeSat, we have facilities developed, which we have a conference and a workshop room. We have ISO 6 clean room, and we have an outdoor ground station for VHF, UHF receiving antenna for telemetry and telecommanding. For our CubeSat, it is going to be a 3U CubeSat, and it will carry two main instruments for the large object in the sky, in the X-ray frequency and in the visual wavelength. For visual, we have two cameras on board, and for detection of X-ray objects, we have IXRD available on board. We will hear about these instruments very soon once our design is finalized and the manufacturing or fabrication will be done soon. We have a radio astronomy lab. In this lab, we have two telescopes. So you can consider this lab as an observatory, radio observatory as well. So one of them is the Decometry Radius telescope. It is basically 4 units of dual dipoles, and the whole structure works to observe any radio information in 20.1 megahertz. So why? Because basically we are specifically looking for observations from Jupiter Io interaction or solar burst or background radio emission from Milky Way. So 20.1 megahertz frequency is the best to look for, and this system is designed only specifically for these type of observations. We also have a 40-meter interferometer. It is comprising of 3 radio dishes of 5 meter, and you can see down in the right side, it's a triangular structure comprising these 3 radio telescope. We have effective telescope size of 40 meter. It has angular resolution of 0.36 degrees overall, and the target objects we have, we basically observe almost covering all the range of objects, but specifically we look for Sun, Cassiopeia A, Centaurus A, Cygnus A, and you can name many other sources that we are observing through this interferometer. So it's a continuous observation of 24-hour, or whenever we have a certain observation to make in certain scenario. We have a high energy astrophysics lab. High energy astrophysics is basically a branch of physics concerning with the physics of high energy processes. And these high energy processes, including the birth of neutron stars and black holes. The research group basically focus on the compact objects and processes. which are concerning the accretion. When they go through accretion either via disk or wind. The main research interest lies in the observation and theoretical interpretation and simulation of creating compact objects in both high mass and the low mass X-ray binary objects. So basically, in short, if I could summarize that, we are looking for the birth and the birth of neutron stars and holes, and we are basically interested in how the two stars interacting through the accretion of mass among each other. So this is also an active lab at the SAASST. Finally, we have Space Weather Ionosphere Lab. We have some instruments, outdoor instruments, ionosphere radar and GNSS receiver. And basically, space weather is a vast area to study. We only focus on the near Earth environment at the moment. And for that, these two instruments, the ionosphere radar and GNSS receiver, are helping us to observe and analyze data and effects of radio space weather on our upper atmosphere. Our main research goals are first the observation and archiving of the data, since this is the first place where the space weather observations are being made in this Gulf region. And the second is that using this data to assimilate it into models to predict the next processes in a certain solar activity. So if it's low solar activity, how our ionosphere should be behave, with high solar activity or in a solar storm, how it should be behaving. And we are continuously publishing results throughout the year. So these are the a little bit of a quick introduction about all 5 labs. If I go through further, I see that we obviously we are funded through some sources. The main source of our funding is University of Sharjah. Thanks to University of Sharjah, that they have been continuously funding for these instruments, these labs to develop. Other collaborations are going on with UAE Space Agency and Mohammed bin Rashid Space Center in different projects area, which we used to have them from time to time. As far as publications from these labs concerned, this is a list of 2019 and 20 list from each lab. And these publications include not only journal papers and conference papers, but also the scientific journal articles for the public outreach, or the other material that we use to publish to educate people in space sciences. Apart from writing material, we also reach public and teach them through research workshops. Up till before COVID-19, we used to have physical workshops here. People come here and attend these workshops. But since last year, we have been conducting workshops online. And these include educational workshops. These includes the workshop on certain trainings like STK, Satellite Toolkit. Is a software that used in all space agencies, very actively used. So workshops, technical workshops like this. And also observatory open houses, general lectures, specialized lectures from experts. And also we are part of UAE Space Innovation Group, this Emirates Space Innovation Group, where we go and participate from time to time to discuss our progress. Finally, we have international collaborations. We have collaboration in 2 big projects like ICRANet and KM3Net. These are the astrophysics and astronomy related project, observational project in Europe. We have a strong collaboration with Istanbul Technical University for our CubeSat project, and we have exchange student MOU signed with other universities like Liverpool, John Moores University, Leicester University, and University of Cologne. These are the development we are targeting for. The first 3 are under certain progress. So data center, machine learning, and artificial lab have kicked off to some extent. So we are working on it actively. The last 3, the balloon and suborbital lab, astronaut center, and robotic laboratory would take a little bit of time, but obviously they are big projects. So they will soon be developing at SAASST. So that's all. That's a quick overview of SAASST from my side. And if you have any questions, please ask.
Thank you very much, Dr. Mubashir. We appreciate your presentation of the research lab. So very nice summary for each lab and so on. just to inform the student and the attendees, if the chat does not show on your screen, please you have to log out and log in again for the chat, because you would like to ask question, because in about 45 minutes you need to register yourself. So write please your full name, your student ID, to be able to get from me your 2 bonus points and also to get a certificate for this workshop. Thank you again, Dr. Mubashir. I believe we are ready for the next lecturer, Mr. Mohammed Rayhan. So he's going to talk about space debris. So please, Mohammed, take the stage, share your screen.
Assalamu alaikum.
Alaikum assalam.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. My name is Mohammed Rayhan. I'm a research assistant in the Radio Astronomy Lab in SAASST. And my talk today will be about what are the space debris. So before we start in this presentation, let's see what happened in May 2021, about 1.5 months before. So let's see what the news that was highlighted in the worldwide in that in someday in May 2021. This is a routine launch for the China, one of the China's missions to the space. To reach the module of the space China's space station. But when the rocket dropped to the LEO or the low Earth orbit, it burned on the atmosphere like this. This is a view from the ISS to the burned debris. This is from the rocket itself. This is a view. Unfortunately, this rocket debris didn't cause any material damage for any properties or in any city. So this is it's called a good luck, but maybe on the upcoming missions or the upcoming space debris re-entry, it will cause us a serial damage for the properties or cause a fatal or kill somebody or kills a group of people. Okay, so as we say, first come first served. The first launched, first fall for the first satellite. It was Sputnik 1. It is a Union Soviet satellite launched 6 years ago and orbiting the Earth for a couple of months, and after that it fell on the Earth atmosphere and burned up. So it was the first satellite, and it was also the first space junk. Let's see, or let's talk about the sources of these space debris. Basically, there are several sources. Number one is the normal launch operating, like booster rockets and fragments from the explosions and collisions of the space devices or in the space and orbital rockets and spacecrafts. So also for the solid rockets, fuel rockets, they use an aluminium as a catalyst. So these catalysts, when burning, it emits aluminium oxide particles. So it is a kind of micro space debris. Also the material aging effects, like this, the Soviet space station Mir. It is a completely space. It became a space junk for many years ago because it aged now and it's not working right now. Also, the leaking thermal control system can cause the space debris. Now, as we see in that video, when the problem is reaching any spacecraft or rocket or anything, reaching the low orbit or low Earth orbit zone. So why LEO, or it's called LEO, why LEO is a critical zone? Why we try to avoid falling in or to avoid reaching any rocket or any space craft to reach the lower layer of LEO. Sorry, LEO. It is one of the orbital zones. It's called LEO, MEO, and GEO. So LEO, it is the closest orbital zone to the Earth surface. First of all, there are a lot of money, a lot of maybe billions or trillions of dollars spent on this zone. So there is a big investment, a huge investment. It's not big investment, like International Space Station in that orbit. It is about 20 kilometers above the Earth surface, and it needs to reboosting for in couple times in a year, because to prevent reaching this or descending this station to the lower IO orbit. Also the iridium telecommunication satellites, the remote sensing satellites, all the observing Earth satellites lay on this layer, and as we see here, Hubble Space Telescope. Also, it is around 540 kilometers above the Earth, and the Chinese space station, the new Chinese space station, also it has it revolves around the Earth in the same zone. So as we see this, the LEO, it is a very crowded zone. A human being invested a lot of money to launch these spacecrafts on this altitude. So it is very important to keep it safe, and it is very important to avoid this instrument to descend gradually to the Earth atmosphere and burn on. Maybe we forgot this one. Yes. So we forgot Elon Musk and his ambitious program Starlink. He's launching hundreds of satellites, small satellites for the internet every month. Okay, so now let's see what the characterization of the space debris. There are almost about 170 million pieces on the debris, smaller than 1 centimeter, and above 670,000 pieces from 1 centimeter to 10 centimeter. So 1 centimeter, it is not a small debris, by the way, in terms of the hazard of collision of these debris with the spacecrafts or with solar panels, like what we will see now. Also, the current amount of large debris, 10 centimeters and larger, is at 30,000 pieces around the Earth. So overall, 98 of these, 98 of 100, around 2 tons debris in the low orbit. So, as we said, the low orbit, the problem with low orbit debris, actually. So the total mass here is an interesting. I found this interesting, very interesting point, because the total mass of the debris, okay, it doesn't for the small debris, it doesn't change, because there is a kind of dynamic equilibrium between the amount of debris we produced and the debris that re-entry the atmosphere. So it is a kind of equilibrium. So the mass, the overall mass of these debris remains constant. Let's see one of these or the risk of the space debris on the orbit. So on the orbit, you can this with a small debris, with a small screw, with a small any piece of metal can cause this massive damage of the solar panel, and it can disconnect this connectors here. So you can damage this solar panel by the collision with any thing in orbit, because there is the speed of these debris and remnants will be very, very high. Also, it can cause a damage on the fuselage itself, the fuselage of the spacecraft or of the telescope or the mirror of a space telescope, any space telescope. So it can cause serious damage on any instrument or any spacecraft with collision. Of course, it is not a joke to see something falling on your head from the sky like this one. This is a fuel tank. fold in the United States of America, and you can see as we see in the video before minutes. This is a re-entry process. So when the small components or small debris falling down, it is not a big deal because it will totally burn in the upper atmosphere. But when we are talking about the large bodies like this one, like this tank, so it can cause a serious damage for on Earth. Let's see the one of the steps to protect ourselves and protect the Earth from
you
this.
have 1 minute.
Yeah. I almost finished. One of these, or the first step, is to tracking the space debris. So Earth-based radars are using for a near debris, and the optical telescope are using for the distant region, such as a geostationary region, space debris or the orbits. So for a distance or for a long distance, it is better to use a telescope. Also, the ISS itself had its own surveying and monitoring space debris system, tracking system. Here, this is a very ambitious also program. It's called Terra. It is a big radar can detecting the space debris on the low orbits. And here is the second step is to clean the sky from the space debris by using lasers or by using a very large network like this one. And maybe in someday this painting will be real. One of the job future of the one of the job opportunities in future will be to clean the orbits from the dangerous space debris. I finished my presentation, and thank you. If you have a question, please don't hesitate.
Thank you very much, Mohammed, for this nice presentation. So we go to the next presenter, talk about near-Earth object. Miriam, please, are you ready? So you can share your screen.
Thank you, Professor. I will share my screen in just a minute. I hope you can see my screen now.
Yes, we do.
Okay, that's wonderful. Okay, thank you, Professor, and thank you everyone for attending this event. And I would like to welcome you to this lecture about the near-Earth objects. And I would like to introduce myself, of course. I am Miriam Sharif, a research assistant at the Meteor Center at the Sharjah Academy for Astronomy, Space Sciences and Technology at the University of Sharjah. So before starting with the lecture, let me introduce you to the outline. That first we will know about what are near-Earth objects are and where do these objects come from. And we will know about the near-Earth objects groups and their classifications. We will talk more about their discovery statistics, spotting or tracking near-Earth objects and impacts of near-Earth objects. And there's an example of an Earth impact monitoring system by Century and ways to avoid near-Earth objects impacts. Okay, so starting with the definition of what our near-Earth objects are. Basically, they are small solar system bodies like asteroids and comets that pass close to the Earth orbit and cause a potential threat to the planet. And in terms of orbital elements, near-Earth objects are asteroids and comets with perihelion distance that as less than 1.3 AU, which is an astronomical unit, and 1 AU is known as the average distance between Earth and Sun. So as you can see here, we have a picture of an asteroid and a comet. And in terms of size, the size range of these near-Earth objects is between like few meters and several kilometers in diameter. And this, you can see from this image, showing the relation between the sizes of some examples of asteroids with the relativity of the buildings. Okay, so moving on to know from where do these objects come from. As you can see, our beautiful solar system. Here we have the sun and the planets. As you can see, there is the asteroid belt, which locates between the planet Mars and Jupiter. And there is the Kuiper belt, which we can find like some asteroids here. So asteroid belts and the Kuiper belt, most of the asteroids be found there. And in the Oort cloud, which is even further, where some of the comets are found there. But mainly the most or the majority of near-Earth objects, they come from the asteroid belt, where and like how they come even closer to the Earth, because some of the objects collide between each other, and then they get to be drifted from the orbit and gets closer to the Earth. And because of some planetary gravitational force, it's used even to drag and attract it to even drift away from its normal orbit. So that's how it comes even closer to our planet. Okay, so, and here we have some like how we can characterize the near-Earth objects. They fall into several groups, such as near-Earth comets that are relatively few and approximately about only 1% of near-Earth objects, but the majorities are the near-Earth asteroids, and they are even there are subclasses or subgroups such as Amur, Apollos, and Athens and Meteor. And there is even another group which is known as the potentially hazardous asteroids. And you can see from the image on the right even some more details about the near-Earth asteroids, and they are actually characterized based on their orbital elements, such as the perihelion distance, the aphelion distance, and the semi-major axis. And as you can see, Amurs, it's like an Earth approaching near-Earth asteroid with orbits exterior to the Earth orbits. As you can see, it's even and it's exterior to the Earth orbit and interior to the Mars, as you can see here. And it is named after asteroid Amur. And for the Apollos, the Earth crossing near-Earth asteroids with a semi-major axis that is larger than the Earth, and it is named after the asteroids Apollo. The Athens is an Earth crossing near-Earth asteroid with a semi-major axis that is smaller than the Earth, and it is named after the asteroid Athens. The Asteroid is a near-Earth asteroid whose orbits that is contained entirely within the orbit of the Earth, and it's named after the asteroid Meteor. So that's about the near-Earth objects groups, as you can see. So if you would like to talk about the near-Earth object discovery statistics, as it have been shown by the early beginning of this event by Professor Elias, as you can see here, it's and from this animation, it's like mapping the position of near-Earth, of all known near-Earth objects at points over the past 20 years, and finishes with like it will finish with the map of all known asteroids as of till January 2018. And according to the asteroid research team that's supported by NASA, the Near Earth Objects Observations program have founded over 95% of near Earth asteroids that they are currently known. And there are now like over 18,000 known near Earth objects, and discovery rates, like on average, it's about like 40 per week. Okay, and here we have some examples of a cumulative number of near-Earth asteroids that is provided from the Center of Near-Earth Objects by NASA. And as you can see from the graph here, we have the discovery date, and there's the cumulative number of the discovered near-Earth asteroids, and the red indicates for the near-Earth asteroids that they are 1 kilometer and more, and for the orange is an indication of the 140 meters and more. That is the diameter, the size of the near-Earth asteroids, and the blue indicates like for all of these groups. And as you can see here, there are some numbers for near-Earth asteroids and the potential hazardous asteroids and near-Earth comets, as can be shown in the graph. And the table below shows some details that with the numbers of the discovered near-Earth objects based on the near-Earth objects groups and per date, like in each. For example, here we have the 27th of June. These are the numbers were discovered per the groups. Here are like more statistics, and they are categorized like by size. And then here we have on the right by survey. The one by size, as you can see, based on the estimated diameter of these near-Earth asteroids, and there are the total of the discovered near-Earth asteroids. And the one in the right shows like the numbers with the perspective of the telescopes that have discovered these objects. So now, how do we spot or track near-Earth objects? So there are two main ways in order to do that: either to use the ground-based telescopes, or with the utilizing space telescopes. That we have an example of the ground-based telescopes, such as the European Southern Observatory, the VLT, the Very Large Telescope they have, as you can see on the left. And on the right, we have the new WISE, which is a Wide Field Infrared Survey Explorer telescope. Like from the outer space, it tends to spot and track near-Earth objects. And you will see in the next slide a video, and a really nice video showing how NASA spots near-Earth objects.
How do we spot near-Earth asteroids? To start, survey telescopes scan the sky. When multiple pictures of the same spot show a speck that's moving, computers automatically check it against a database of known objects. If there's no match, it gets added to a list of objects to confirm. And if it looks like it'll pass very close to us, we give it top priority. Then it's time to call in reinforcements. More astronomers from NASA, other institutions, and even the amateur community submit additional observations. Each new data point helps refine the projected path. This asteroid is going to fly right on by. All the info will be posted online, so it can continue to be tracked and monitored. Nice work, Planetary Defense Team. Keep watching the skies.
Right. Well, actually, in this slide, you will see an example of like where in 2004 there was a concern of an asteroid that it could possibly hit the Earth in April 2029. This asteroid is the Apophis asteroid, and as you can see from the animation, it's the orbital trajectory of this asteroid, and as it's like zooms, they can pass safely from the Earth, and on that particular day. So Earth is safe from this asteroid for like even 100+ years. And as you can see, like once the asteroid comes close to the Earth orbit, the Earth gravity slightly deflects the trajectory of that asteroid. And the motion in this animation has been speeded up like 2,000 times of the real time. Moving on some examples from the history of near-Earth objects impacts. And as like scientists have found plenty of evidence that there are large near-Earth objects have hit the Earth many times in past years, with like more than 160 large impact craters currently are known around the world. So the first example is to be recognized in an impact crater was in Arizona, the 60 100 meters wide crater. This near-Earth object that caused that it's thought that it was like just about 40 or like 50 meters wide. And as you can see, the image on the top right. And there's another example of an impact site of the coast of Yucatan Peninsula in Mexico that is now buried by the seafloor, and it's thought by some to be the event that contributed to the extension of the dinosaurs over some like 65 million years ago. So the image on the bottom right shows that impact. And there are there is a more recent time example that even it was shown by the start of this event by Professor Ilyas about Tunguska event in Russia. And as you can see here, an example, a picture of the affected area that because of the shock wave that have flattened that area and like over 2,000 square kilometers of trees in all directions. And until today, there are no trees are growing up in that spot. Okay, so because of the risk that could be caused by the Earth impact, the near-Earth objects impact. So
1 minute left, Mariam.
Yes, sure, Professor. So there is an Earth impact monitoring system by Century, and as you can see, that Century is a highly automated collision monitoring system that continually scans most current asteroids catalogs for possibilities of future impact with the Earth over the next 100 years. And you can see here some examples of tables that are retrieved from the Center of Near-Earth Objects. And so, like for example, if we know that there are a potential of an Earth impact, so what we can do about that and how to avoid such an event. So if we know like in an advance, like over 20 years, that we can plan to send a rocket or a spacecraft to try to destroy or to push that object away from us, or we can have like more gentle or cute ways to do that is to paint the asteroids with a bright white paint that will change how the way it reflects the sunlight, and it will be the thermal effect. It will be different. That's not equal, so it will affect how it orbits, and that it could be sufficient to push it away from its orbit. And even we can like land the small rockets in that asteroid in order to push it away, or we can cast a net to grab and pull the asteroid away, as you can see from the picture in the bottom. So that's all what I have about the near-Earth objects presentation. And thank you for listening, and thank you for your time.
Thank you very much, Miriam. I will leave the question at the end. There is one question asking about how would it be possible to spray paint? So that I will answer to that at the end of the presentation. So to be fine, inshallah. Thank you very much, Miriam, for this nice presentation and for all the data you presented. And now let me go to the next lecturer, Selma Sobhi. So please, Selma, you can share your screen now.
Okay. Can you see my screen, Professor?
Yes, we do. Go ahead.
Hello, everyone. My name is Salma Subhi. I am a research assistant at the Meteorite Center at Sharjah Academy for Astronomy, Space Sciences and Technology at the University of Sharjah. And today I'm going to talk about the meteorites collection at SAASST. These wonderful pictures here represent the inauguration of the meteorites collection by His Highness Sheikh Dr. Sultan bin Muhammad Al-Qasimi, member of Supreme Council, ruler of Sharjah, and president of the University of Sharjah on May 2019. The collection, or the meteorites collection, is unique for being one of the largest collection of meteorites in the world. They include more than 8,000 pieces of different types of meteorites from around the world and also from a variety of places in the solar system. The collection composed of different types of meteorites. The iron meteorites, which are almost completely made of iron, nickel, metal, they consist mainly of iron and also some nickel, amounts of nickel and trace elements. We have some meteorites, like the stony meteorites, which mostly have the silicate minerals. And we can find the two groups of the stony meteorites, the chondrites and the achondrites. We have also the stony iron meteorites, which have nearly equal amounts of iron, nickel, metal, and silicate minerals. And we can find also the two groups of the stony meteorites, the pallasites, and we have also the mesosideриtes. The collection also includes few Martian and lunar meteorites. These meteorites were originated on the Moon and Mars, then ejected into space by large asteroids or comet impacts and later falling on Earth. And we can see here in the picture, we can see a sample here of a meteorite that it comes from Mars and this one from the Moon. So they can be originated or not only from the asteroids, they could come from, they could be ejected from Mars and also from the Moon. In this case, we call the rocks which comes, or the meteorite which reach the Earth from Mars. Okay, we call it the Martian meteorites, and the one regarding the Moon, we call it the lunar meteorite. Meteorite collection advantages. The variety of meteorites collection represent fingerprints of the early conditions and processes in the solar system's history since 4.6 billion years ago. It supports also the scientific research studies and other services in the development of astronomy and space sciences. It raises also the awareness and offer a distinguished opportunity for the academy visitors to observe and nourish their knowledge about meteorites. Thank you so much.
Thank you very much, Miriam, for this lecture. So as Miriam says, so we have a very large collection of these meteorites from different parts of the world. We have big ones. The biggest one is about 1.2 tons, so 1,200 kilograms is pure iron and nickel. Some other ones have mass about 600 to 200 to 50 to 20 kilograms. And I will challenge any one of my students to carry a 20 kilogram meteorite. So he or she will break her back. So we have a very nice collection, and hopefully when the academy is open, when this pandemic is over, so you can visit us and you can visit our meteorite collection. So it is a very beautiful one. You may ask, what do we do with it? Well, it is very important to take these stones and analyze them. So as it has been presented, so we do a meteorite analysis. So analyze, why is it important? Because we need to know how did the solar system form. Meteorites are very different. As Selma said, it all depends upon how far away they formed from the sun, and because how far away they formed from the sun, so we have different chemical compositions. So to have a piece of meteorite in your hand is to have a piece of history of the solar system, meaning that you will know how did the solar system form. So we believe today in the solar nebulae theory that a huge molecular cloud collapsed under its own weight, and as it was collapsing, it became hotter, hotter inside. Our star was formed, and the remaining debris of this huge molecular cloud formed the planets, from the moon, and from the moon anything else. So it is very important to study these meteorites, and hopefully our meteorite collection will help to understand the formation of the solar system once we start a fully analysis of all the samples. Yes, it may take a lot of time, but we may take samples from even there to understand. Thank you again, Selma, for this nice presentation of our meteorite collection. So now let's go to the next lecture. Okay, so let us present the UAE Meteor Monitor Network, which is sponsored by the UAE Space Agency. So let me ask Anas. Anas, are you ready? So you can share.
Yes, Doctor. Assalamu alaikum.
Walaikum salam. Go ahead.
1 second. Okay, assalamu alaikum everyone. My name is Anas Omar, and today I'll be presenting to you the UAE, our project, the UAE Meteor Monitoring Network. The primary mission of the UAE MMN is to establish a unique meteor monitoring system in the Middle East and North Africa, and it aims to observe the sky and detect the meteors and fireballs and space debris, and afterwards analyze them and approximate the possible landing locations of them. And in addition to that, another aim is to take part of the UAE Space Situational Awareness, where we engage the public with meteor-related events. As mentioned earlier by Dr. Mubashir, we have 3 towers that that monitor the sky. The first one is located in Sharjah, and the second one is located in Liwa, and finally our third tower is located in Al Ain at Al Yahar. Far to the left, the first picture shows the tower that we have here in Sharjah. The second picture in the middle shows the one we have in Al Yahar, and the third shows the one we have in Liwa. The fourth picture represents the structure or the sketch of the structure that we have. At the bottom, we have an air-conditioned room where we have the computers running in order to control the cameras located at the top. And as you can see here in this picture, we have it is a top view of the tower, where on the ring you can see the 16 cameras, and the 17th camera is located in the middle here. I'm not sure if you can see it, if you can spot it. The one in the middle is called the all-sky camera. So furthermore, with more details about the camera, as we said, we have 17 cameras. The one in the middle is the 2mm camera located in the middle, and the rest of the cameras 10 of them are 8mm cameras, and 6 of them are 6mm cameras. And they're all distributed in a set way where we need to cover the sky as much as possible. So they're not distributed randomly. So shown in this map, we can see that the red boxes represent the 8mm camera, and the blue boxes represent the 6mm camera. And this is the way they cover the sky as set by our team here at the Academy. Data handling and transfer. So as we said earlier, that the towers are responsible for the data collection, and by the end of the month, when we have the data ready, our team here at the Academy filter the data that we have, because there are some detections that are false detections or not needed. So they do the filtering remotely from here, and afterwards we collect the data from the towers and we store them here at local hard drives and on a cloud as well. This is a presentation of what type of data that we collect, raw data. So as you can see here, we have around 8 to 9 files that are selected. These are the files for just one detection by a camera. So for further analysis, because we use 3 different softwares, for further analysis, we need different skins or different masks for the same detection, and we need different formats and files as well. So we need all these files to do the further analysis. And imagine the amount of work that the research assistant has to do in order to filter these files. Up to the next slide, we have an example of the skins, the filters, and what kind of data that we deal with. And we were going to start with the examples of captured meteors by the UAE MMN. Starting with this image, this is one of my favorite actually, because it stacks a couple of detections in one picture by one camera. And so as you can see here down at the bottom, this is for May 2019. This is throughout the month. So starting from the beginning to the end of the month, they collected the pictures from one camera and they stacked them in one image. This is a clip that shows a meteor that got detected during the day. As you can see, the time is right before sunset. It's around 5:30. This gives you an idea of how bright the meteor could be, so imagine how bright will it be, or how visible will it be if it was detected during the night. Another example of a bright meteor. This was detected at around 12:45, around 1 a.m. 2 more clips, 2 more videos of detected meteors. And some more observations. This is a really bright one. Now we're going to talk about the double and triple detections. So by double and triple detection, I mean we have three towers distributed from Sharjah to Abu Dhabi to Al Ain. So a double detection is when 2 towers detect the same meteor at the same time, and triple detection is when 3 towers detect the same meteor at the same time. And with that, it helps us pinpoint what is the location what is the location where this meteor could land. And obviously, if we have double detection, we have a more accurate result, and triple detection will give us even more accurate results. This is a clip that shows a double meteor, not a double detection. It's a double meteor, where in one clip a camera was able to detect 2 meteors at the same time. And in this video over here, we will have detection of a MyStar satellite. As you can see, it will be shown over here. One second, let me repeat the video over here. This is a picture of it. And this shows a rocket booster. So as we said earlier, we do not only detect meteors, we detect fireballs, we detect space debris. Now onto the software. Sonotaco.com is where we found our 3 applications. So we use the UFO capture, UFO analyzer, and the UFO orbit. As we mentioned earlier, the UFO capture is the one we use, is the one we have at the tower, which runs the cameras. And over here, this is the user interface. So we, after connecting the cameras with the computer, we run the software. We have to run 17 windows from this in order, because each one of them will run a specific camera. So going through the details here on the left side, this is camera number 16. It is an 8mm camera. And the serial number, obviously the observer name, which is us. This is our old name, SAASST. Location ID, home, which represents the academy. Longitude, latitude, altitude. These numbers differ from one camera to another. This is why we have to have a window for each and every camera. Going through to the next slide, this is one of the most interesting pictures that I actually saw using our system or our software, because it shows that we also detect birds, and while dealing with birds, we have to obviously deal with birds' remainings, and that means that we have to clean the cameras and clean the lenses, because it also covers the field of view of and by that it will affect the number of data that we collect. This is one of the main difficulties that we face. Up to the two coming applications, we have the UFO analyzer and the UFO orbit. And using these 2 applications, we get the presented information: the radiant sheet, orbit sheet, trail map, and ground map. The radiant sheet shows us the source of the meteor. It tells us where did this meteor come from. And the orbit sheet, as you can see over here, it shows the planets while they orbit the sun. These are the orbits. And the yellow orbits, I do not know if it's visible for you. The yellow orbits represent the meteors orbiting our planet. The trail map over here shows the trail of the meteor. So as if we're looking to the sky from ground, we're looking to the sky. This is the trail of the meteor. However, the ground map is a top-bottom view, so it shows the trail of the trail of the meteor. And as you can see here, it is a double detection. This is the tower that we have here in Sharjah, and this is the tower that we have in Liwa, and they both detected the same meteor. The network timeline. The first station was built in the 5th of September 2018, and by the end of the same month, we built the station we have in Liwa. And in the 21st of January 2019, we built the tower we have in Al-Yahar. Network statistics. From the beginning of September 2018 till May 2021, we have detected a total of 34,667 meteors, and 4,411 of them were double detections, and 410 of them were triple detection. This is a presentation of the detections that we have, the data that we have, and as you can see here, it varies from one month to another, from a location to another. As you can see here, the three towers could not give us the same exact number of detections, because it depends on the location, it depends on the light pollution, and so on. Current researches. At the moment, given that we have a huge number of data, a huge number of information, it gives us a wide range of possibilities. We can study, we can do some analysis. We can study the relation between the detection and the light pollution. We can study fireballs. We can study the moonlight effect. So given that we have all these possibilities, we have done many different publications, and we have published in journals, we have presented in conferences, and we have some upcoming work as well. We presented the UAE MMN in COSPAR in this year 2021, and we have at work in progress, which is the 2-year analysis of the UAE MMN observations, and we have 2 accepted abstracts in the IAC 21. Future extensions. We're looking into upgrading the system by adding 3 or 4 towers. As you can see here in the picture on the right, we have the 3 towers marked with the green circles, and the 4 red marks represent the possible new locations of the towers. In addition to that, we're looking into upgrading the cameras that we have on the towers, because by upgrading them, we will have a clearer view, and that will give us more data, and it will give us more accurate results in terms of analysis. And thank you very much.
Thank you very much, Anas. It was a very nice presentation to give an overall summary of the UAE Meteor Monitoring Network as sponsored by the UAE Space Agency. Thank you very much. We'll leave the questions at the end, hopefully. And now, so let me go to our last lecture. Mr. Mohammed Talafha, are you online?
Yes, Dr. I'm with you.
Please, Mohammed, you can share your screen.
السلام عليكم ورحمة الله. أنا محمد طلافحة، راصد فلكي ومساعد باحث في أكاديمية الشارقة في مرصد الشارقة الفلكي. سأقدم اليوم إن شاء الله كيف نكتشف ونتتبع هذه الكويكبات من خلال مرصد فلكي قد لا يكون بحجم كبير، ولكن أيضا سنرى كيف يتم اكتشاف هذه الكويكبات على مستوى العالم، وكيف نستطيع الاستفادة من هذه الأرصاد كباحثين موجودين حول العالم. النقاط التي سنتكلم عنها: كيف نصنف، زميلتي مريم قامت بتصنيف هذه الكويكبات بشكل جيد، وسنتكلم بشكل أكثر عمقاً عن كيف نستطيع أن نرصدها، ما هي التلسكوبات التي تقوم بمسح السماء وكيف تكتشفها، ما هي الآلية والبروجرس لعملية الاكتشاف، وأيضاً الأعمال التي نقوم بها من خلال مرصد الشارقة، عملية رصد وتتبع هذه الكويكبات، ومن ثم بالنهاية كيف نستخدم السوفت وير، أو سنتكلم عن السوفت وير بشكل بسيط. هذه باختصار هو سلايد واحد يختصر عملية التصنيف لجميع الأجسام في السولار سيستم أو المجموعة الشمسية. إذا ابتعدنا عن الكواكب المعروفة ال8، باقي الأجسام هي متداخلة، تعتمد على كيفية التصنيف، المسافة، وهل تتقاطع مع مدار الكرة الأرضية أم لا. نرى هذه عملية التصنيف متداخلة مع بعضها البعض إذا ما استثنينا الكواكب. عملية الرصد How to observe asteroids، ببساطة سأقوم بتبسيط الموضوع بقدر ما أستطيع. عام 1801 كان هو أول اكتشاف لأسترويد. عملية الاكتشاف كانت بالطريقة نستطيع أن نسميها الطريقة الصعبة أو الطريقة المانيوال البسيطة، بأن نقوم برصد موقع بالعين المجردة، ومن ثم نقوم بمقارنة هذه الأرصاد مرة بعد مرة حتى نرى إن كان هناك أي جسم يتحرك بشكل بسيط. أول اكتشاف لهذا الأسترويد هو الأسترويد الأكبر ما بين جميع الكويكبات، اللي هو سيرفس. طبعا نرى الآن ببساطة بأنه هذا الاكتشاف هذا الكويكب ذو الحجم الأكبر نستطيع أن نكتشف مثل هذا الكويكب ذا الحجم الكبير بهذه الطريقة، ولكن مع تطور معرفتنا للأجسام في المجموعة الشمسية وأقطارها المختلفة التي تتراوح ما بين المئات الكيلومترات إلى الأمتار، لا تعود هذه الطريقة بالعين المباشرة أو حتى بالتلسكوب سهلة. فمع تطور عملية الأرصاد وتطور الأجهزة التي نقوم بالعمل عليها، باتت هذه العملية وعملية الاكتشاف أكثر سهولة وأكثر سرعة. الآن أحد الفيديوهات عرضته الزميلة مريم بأن نقوم بأرصاد من خلال ما نتوفر عليه الآن ونستحوذه من تلسكوبات كبيرة الحجم وكاميرات دقيقة وحساسة. نقوم بمسح السماء بشكل يومي من خلال التلسكوب وهذه الكاميرا، ونمسح السماء أو هذه المساحة نقوم بمسحها أكثر من مرة في اليوم في الليلة، ونقوم بعملية مقارنة سريعة لكل مساحة على حد ذاتها لنرى إن كان هناك أي أجسام تتحرك تغير موقعها. هذه عملية الأرصاد الآن منتشرة بشكل مهم. هناك أكثر من تلسكوب تم إنشاؤه لعمل مثل هذه الأرصاد. سنرى بعد قليل بعض هذه الأرصاد أو هذه التلسكوبات. سكاي سكان تلسكوبس هي هذه التلسكوبات، أولها يسمى كاتالينا والآخر بان ستارز. أيضا لدينا أطلس ولينير. جميع هذه التلسكوبات لها خصائص فيزيائية تقوم بعملية الرصد. هذه الخصائص مهمة لتسهل عملية الرصد وتزيد من كمية المساحة التي نقوم برصدها في كل ليلة. طبعا هذا النظام من هذه التلسكوبات يسمى الإنذار المبكر. الإنذار المبكر يأتي من فكرة بأنه يجب علينا بعد معرفة وفهم الكثير من هذه الأرصاد وهذه الكويكبات التي قد تهدد الكرة الأرضية، نشأت الفكرة وخاصة بعد عام 1995 لنقوم بعملية مسح السماء اليومية ومعرفة هذه الكويكبات التي تتحرك مباشرة نحو مدار الأرض. طبعا معظم هذه الكويكبات تتحرك في منطقة ما بين المريخ والمشتري، ولكن هذا لا يعني بأن يكون بعض هذه الكويكبات قد تتحرك بشكل مختلف نحو الداخل، بمعنى داخل المجموعة الشمسية. واحد من الأمثلة اللي هو تلسكوب أطلس. هذه الموجود لدينا هذه الأرقام تمثل الصفات الخاصة بهذا التلسكوب. من أهم هذه الصفات الفيلد أوف فيو، بمعنى كم يستطيع هذا التلسكوب أن يرصد في كل صورة. 7 درجات في السماء تعتبر كبيرة إذا ما قارناها مثلا بحجم ومساحة القمر البدر، هي نصف درجة. فلاحظوا بهذه 7 درجات تعتبر مساحة كبيرة. طبعا المساحة الكبيرة تحتاج إلى بحث أكثر. طبعا عملية البحوث و اكتشاف هذه النقاط المتحركة، سأريكم بعض الأمثلة طبعا لمثل هذه الصور، تقوم بعملية أوتوماتيكية، ولكن لابد بالنهاية من التدخل البشري للتأكد من عدم وجود بعض هذه الكويكبات التي لم تتم ملاحظتها. طبعا مثل هذا التلسكوب يعمل يوميا، في كل ليلة يعطي تقريبا 1000 صورة، يعني كمية هائلة من المساحة وكمية هائلة من الداتا تحتاج إلى عمل كبير لنقوم بمراقبتها وتحليلها. سأريكم قد يكون بعد السلايد التالي. هنا منذ عام 2002 هذه ورقة من عام 2002 توضح التلسكوبات التي تعمل على اكتشاف الكويكبات، ونلاحظ هنا عملية الفروقات ما بين التلسكوبات. المتخصصين بالتلسكوبات يستطيعون معرفة وملاحظة الفروق ما بين تلسكوب وآخر من ناحية مثلا الأف نمبر، البكسل سايز بالنسبة للتلسكوب. كل هذه الصفات تساعد على القدرة على رؤية واصطياد مثل هذه الكويكبات. مثلا هذه أحد الأرقام الماجنتيود بمعنى خفوت أو إضائية هذا الكويكب، وتعتبر هذه الأرقام منخفضة جدا. هذه الأرقام هنا تعتبر خافتة، لذلك لديها قدرة، هذه التلسكوبات لديها قدرة على المنافسة واكتشاف ورصد مثل هذه الكويكبات بشكل أسهل. هذا الجدول يوضح كمية الاكتشافات التي حدثت منذ عام 1995. إذا ما لاحظنا بالبداية كان هناك فقط 33 اكتشاف لمثل هذه الكويكبات تقريبا، ولكن إذا ما نظرنا إلى عام 2020 طبعا موجود 2021 ولكن ما نزال نحن في منتصف العام. في عام 2020 بلغت الاكتشافات ما يقارب 3000 كويكب. طبعا من ضمن هذه التلسكوبات قد توقفت عن الرصد، من ثم بدأت تلسكوبات جديدة وتطورت كاتالاين وبان ستارز، نيو وايز وأطلس. all others هي بعض هواة الفلك لديهم تلسكوبات ويقومون بعملية الرصد والاكتشاف. نلاحظ الفرق الهائل ما بين عام 1995 و2020 في ارتفاع كمية هذه الكويكبات التي تم اكتشافها ويتم اكتشافها في كل يوم. هذه صورة من تلسكوب أطلس كيف يقوم بعملية مسح السماء. إذا ما لاحظنا طبعا الفرق بين الصورتين، هذه موجودة على موقع نفس موقع التلسكوب نفسه، يقوم بإظهار كمية المساحة التي يقوم برصدها في كل ليلة. هذه على اليمين هنا تظهر في بداية عملية الأرصاد، وهنا تقريبا قبل نهاية عملية الرصد، فنلاحظ كمية المساحة من السماء التي يقوم برصدها ومسحها، وجميع هذه في كل مربع هنا يعني عدة أرصاد، بمعنى 4 صور لكل موقع نقوم بمتابعته وملاحظة إن كان هناك كويكبات تتحرك وتتغير في موقعها بالنسبة للنجوم. هذه الزائد عدد الاكتشافات أيضا بالنسبة لهذه التلسكوبات لينير وسبيس ووتش ليونز كاتالاينا. نلاحظ هذه الأسترويد التي يزيد قطرها عن 1 كيلو متر. في هذه التطور مع تطور التلسكوبات وزيادة حجمها، على ما أعتقد وبمثل هذا الجراف يوضح بأننا قمنا باكتشاف العديد من هذه 1 كيلومتر بمعنى الكبيرة، وبدأ العدد بالانخفاض، ولكن أيضا بسبب الانخفاض المقصود فيه بأنه قمنا بمسح معظم هذه الكويكبات الكبيرة. ولكن بالمقابل بسبب ازدياد حجم التلسكوبات، مثلا على سبيل المثال بان ستارز تلسكوب قطره 1.80 متر، فهو يعتبر كبير جدا. وبسبب هذا التلسكوب وقدرته على الرصد نلاحظ ازدياد كمية الاكتشافات. تلك الكويكبات الصغيرة التي يقل قطرها عن كيلومتر وبعضها بالمئات الأمتار، الآن نستطيع أن نرصدها ونحدد مدارها ونعرف تماما أين تتجه. فدائما أبدا في كل عام تزداد كمية الاكتشافات بالنسبة لهذه الكويكبات. أيضا هنا توضح هذه الصورة فقط في 26/6 الماضي. هذه الصورة توضح كمية المساحة المرصودة والممسوحة من السماء خلال 26 يوم، بمعنى تقريبا نصف السماء تقوم هذه التلسكوبات، طبعا من كل التلسكوبات تقوم بمسحها ومعرفة كل شيء في هذه المساحة. على اليمين هنا في الطرف على اليمين يوضح حتى يوم 26/6 يوضح عدد الاكتشافات في كل شهر. مثلا في هذا الشهر إلى الآن تم اكتشاف 150 نير إيرث أوبجكت و9 بلانت ديسكفرد اللي هي تكون في المين بيلت أسترويد، 155 كويكب. طبعا هذه الكويكبات قد تكون صغيرة. وبالنسبة للمذنبات تم اكتشاف 4 مذنبات. لاحظ كمية الأوبزرفيشن فقط في هذا اليوم أو في هذا الشهر هو 2 مليون عملية رصد، بمعنى هناك عمل كبير جدا، عملية مسح كامل للسماء ومراقبة يومية من هذه التلسكوبات التي ذكرنا. كلوز أبروتش هي نير إيرث أوبجكت التي ستقترب من الأرض خلال هذه الفترة القادمة منذ يوم 27/6 وحتى نهاية اللي هو 12 يوليو، توضح هذه الكويكبات بالأقطار والمسافات بيننا وبين هذا الكويكبات. طبعا جميع هذه الكويكبات يعني خطورتها منخفضة جدا بالنسبة للأرض لأنه المسافات تعتبر بعيدة. مثلا هذا الكويكب 2020 AD1 يعتبر قريب 2.8 لونر ديستانس، بمعنى المسافة ما بين الأرض والقمر، ولكن قطره ما بين 10 إلى 33 متر، وهذا القطر غالبا سيتم إيقافه من خلال الغلاف الجوي، بمعنى الغلاف الجوي سيتكفل بالدفاع عن في حال أنه وصل إلى الأرض، ولكن هو فقط سيتقاطع مع المدى. طبعا من خلال هذه الأرصاد التي تحدث بالذات مع تلسكوب بانستارز كان لنا مشاركة مع هذه الداتا، كمية الداتا التي استخدمناها، ومن خلال مسابقة عالمية قمنا باكتشاف كويكبين. هنا يظهر هذا الفيديو كيف يتحرك طبعا باللون الزهري البينك. هذا هو الكويكب الجديد، أعطي رقم P119 BTS، وأيضا الآخر هنا يظهر هذا الكويكب الآخر. هذه كويكبات صغيرة ولكن تم اكتشافها بالتعاون ما بين تلسكوب بانستارز وتحليل هنا في مرصد الشارقة. هي كويكبين، وطبعا هناك العديد من هذه الاكتشافات في المستقبل إن شاء الله. إذا ما تكلمنا من خلال هذه المنظومة، بالنهاية لدينا تلسكوب الشارقة أو مرصد الشارقة، أيضا نستطيع من خلاله رصد هذه الكويكبات وتتبعها، وأيضا نستطيع الاكتشاف. ولكن إذا ما لاحظنا الفرق ما بين تلسكوب مثلا بانستارز بقطر 1.80 سنتيمتر وتلسكوب الشارقة الذي يصل قطره تقريبا إلى نصف متر، هناك فرق في قدرة الرؤية على هذه الأجسام الصغيرة. ولكن بالنهاية الأرصاد ستؤدي بالنهاية إلى اكتشافات. هو هذا تلسكوب أو مرصد الشارقة. هذه التلسكوبات الثلاثة، إذا لاحظت هناك 3 تلسكوبات هنا في هذه الصورة، 3 تلسكوبات. نحن نستخدم بالنسبة للكويكبات رصد التلسكوب الأكبر اللي هو 17 إنش تقريبا 43 سنتيمتر. هذه الصفات ومواصفات التلسكوب والقدرة على الرؤية 15 ماجنتيود إذا ما لاحظنا وما قارنا مع التلسكوبات الأخرى تصل إلى 19 و20 و21 ماجنتيود. هذه بعض الأرصاد 2014 JO25. هذا رصد من مرصد الشارقة، تتبع لواحد من النير إيرث أوبجكت الذي عبر قريبا من كوكب الأرض بقطر 818 متر. هذا واحد من الأرصاد. أيضا هذا الكويكب هنا 1998 OR2 قطره 2 كيلومتر. أيضا هذه أرصاد من مرصد الشارقة، تم رصده في 28 و 29 أبريل الماضي في عام 2020. على اليمين هو الفيديو يظهر التلسكوب يظهر الكويكب الأخير من خلال مرصد الشارقة عملية رصده. إذا تلاحظون هناك نقطة بيضاء تتحرك ما بين النجوم، هذا هو الكويكب كيف يتحرك. طبعا كلما كان قريبا من الأرض تكون سرعته عالية، وهذا يعتبر كويكب ذا سرعة عالية يتحرك ما بين النجوم. في هذا الفيديو الآخر على اليسار يوضح لحظة اقتراب الكويكب من كوكب الأرض وابتعاده مرة أخرى. طبعا هذا الكويكب لديه مدار واضح ونقوم بعملية الأرصاد. بسبب صغر هذا الكويكب نستطيع رصده في المناطق القريبة من الأرض ليكون يعني يعكس ضوء بشكل جيد نستطيع أن نراه، ولكن عندما يبتعد ينخفض مقدار الماجنتيود له ويعود غير مرئي بالنسبة للتلسكوب. طبعا الفكرة من هذه الأرصاد نقوم بإرسال هذه الأرصاد كتقرير للاتحاد الفلكي الدولي، والذي يعتبر مرصد الشارقة مرصد معتمد لمثل هذه الأرصاد. تم اعتماده في الأشهر السابقة لنقوم بعملية رصد الكويكبات وإرسال هذه التقارير إلى الاتحاد الفلكي الدولي ليقوم بدوره، ومن خلال مناصب مختلفة حول العالم ليقوم بإعادة تشكيل المدار مرة أخرى والتأكد من دقة هذا المدار لأي كويكب، وذلك للتأكد بأنه بعيد عن الاصطدام من الأرض، وأن هذا الكويكب له مدار لا يتقاطع تماما أو مباشرة مع كوكب الأرض. واحد من أكثر الكويكبات خطورة اللي هو يسمى أبوفيس 99942، قد تكونوا سمعتوا به خلال الأشهر الماضية. قمنا في مرصد الشارقة برصده وإرسال للتقرير مدار، وهذا يعتبر الكويكب من أكثر الكويكبات خطورة واقترابا من كوكب الأرض، سيعبر في السنوات القادمة بتقريبا على بعد 35,000 كيلومتر، وهذا تعتبر مسافة قريبة جدا بالنسبة لكوكب الأرض، ولكنه ما يزال الخطورة بعيدة ومنخفضة بالنسبة لي هذا الكويكب. طبعا هذه أرصاد من مرصد الشارقة، تقوم زميلتنا فاطمة الآن بالعمل، وهي طالبة الماجستير، تقوم بالعمل على مثل هذه الأرصاد لنشر البحوث الخاصة بهذه الأرصاد. أيضا في الجهة الأخرى لدينا اللي هو شارجا لونر امباكت اوبزرفاتوري، وهو التلسكوب المخصص لرصد هذه النيازك الصغيرة إن صح التعبير أو الصخور الفضائية الصغيرة التي تصطدم بسطح القمر. طبعا نعلم بأن سطح القمر أو القمر لا يوجد حوله غلاف جوي يحميه كما الأرض، لذلك أي جسم صخري يصطدم فيه يؤثر فيه بشكل مباشر، وتتحول الطاقة الحركية إلى طاقة حرارية جزء منها على شكل ضوء نستطيع أن نرصد من خلال هذا التلسكوب. بدأ العمل بهذا التلسكوب 1 مارس 2020، وإلى الآن قمنا برصد 8 اصطدامات قمرية طبعا على مستوى العالم، ولدينا شراكات جيدة مع وكالة الفضاء الأوروبية لمثل هذه الأرصاد. هذه الصورة
1 minute left محمد، دقيقة إن شاء الله.
إن شاء الله. هذه الصورة توضح أول اصطدام قمنا برصده من خلال هذا التلسكوب، وهذه في نفس اللحظة قامت وكالة الفضاء الأوروبي برصد نفس الاصطدام، وكان هناك تعاون علمي ما بيننا، وهذه منشورة في وكالة الفضاء الأوروبية هذا الخبر. هذه عن قرب عملية التحليل، وشكرا جزيلا.
Thank you very much, Talafha, for this very comprehensive lecture about asteroids, the way we observe them, and so on. Let me open the floor for questions. So please, if you have any questions, you can address it to any of the lecturer. So please, you can use the chat. You can use your microphone directly. So please, any questions? There was a question, Mariam, are you around?
Yes, Professor.
There was a question from one of my students asking, how can we paint such a big asteroid to make it more reflective and so on, so the sunlight can push it and so on. So you may have maybe a 1 kilometer size asteroid. So how can you paint it? So what's the idea behind?
So that was just like a conceptual approach or design that in order to like spray or spray paint the asteroids, but they are like mostly for like small objects that in the way that it will be like coated in like in a white more color, that it will change the way that it reflects the sunlight, and based on that the heat, it will be not equally heated like the full asteroid. It will be overheated in a place and not in the other, so that will affect and how to it could change its orbit. So
yeah, I like that picture when it says go away.
Yeah.
So hopefully we can through one of this. Any questions, please, from the audience? There's a question from Ahmed Darai. How can we utilize machine learning and deep learning in fitting the meteors data for the UAMMM? Ahmed Darai is from the UAE Space Agency. Mariam?
Well, yes. So the machine learning at the Meteorite Center, it is basically utilized into for like two approaches for like meteorite recognition and meteor detection. It is currently the group is training a model that utilizes the database or the data set. It's from the UAE MMN network project, that the captured meteors and the other captured object, as my colleague Mr. Anas have mentioned, about that the network captures like any movement in the sky. It's not necessarily a meteor. So utilizing the machine learning techniques, that it can classify if this object is a meteor or it's another object, or like a false detection. So because what we are doing now, that we are manually filtering the files, the captured files, and utilizing the machine learning would help in saving time. And so, yeah, so that's what I have.
Yeah. Mr. Ahmed, so you would like more information, so you can email Aisha by next week when she will be back, and you can get more information about it, or you can read some of our papers about it. And I believe during our monthly report, we report those references, so you can check them out and see exactly what the Meteor Research Group is doing. Any more questions, please, from the audience? I know that my students are leaving because some of them have class at 12 o'clock. That's fine. Any more questions, please? Okay, we have a question from Abdullah Al-Hamadi. I have a question to Mr. Anas regarding the approximation impact position of the meteorite he talked about at the beginning of the presentation, but I don't really get it. Is it calculated manually for now, or there is any software? Can you say something about it, Anas? If Anas is around. Well, if I may answer this, or Mariam, you would like to answer it?
It's okay, Professor. You can go ahead.
Okay, so the main thing here is to have this double and also triple detection. These are very important. In the application, when you have a double or triple detection, so the application can help us to pinpoint out the possible location. But the possible location may be quite big. It's maybe 1 kilometer square or something like that. That's why I would like to do much better than that. So that's why having 2 or 3 more towers will make the search area much smaller. So once we have the region, there is another unit. I believe we don't mention it, the drone unit. So we're going to send a drone. In that drone, there is a specific application that we look for meteorite and meteor wrong. So it will recognize. So also my research group like Aisha and Awais, Mariam, and also some other students have also done some successful experience with this. I believe the results are very, very promising. So once we have the location where this meteorite has fallen, so we can send our drone to look for this. My laptop is going to die. Let me get my power. So we can send our drone to look for this meteorite. So it is a very complicated problem. It's not an easy task to do. So we're getting there day after day, and we are learning a lot about how to detect meteors on the ground. Thank you for asking, Abdullah. Any other?
If I may
Yes,
add,
please, Mariam. Yes, please, Mariam.
Yeah, the software used for the UAMMN, like after capturing and analyzing, utilizing the UFO orbit, we have like an estimated trajectory of the meteor itself, with utilizing the inputs like such as the initial velocity and the estimated the mass. So like we can go further for like some calculations, triangulation calculations, in order to estimate that expected area that meteor could fall. But like the software that we have, it doesn't like do it like directly. We don't have like a ready software for that.
Yeah. So hopefully we'll get someone specialized in software programming, and we can work out session application in the near future. Okay, so I don't want to hold your loss. So I would like to thank every lecturer for his presentation. I believe we learned a lot today. We covered a lot today, and hopefully that everyone has gotten something from these 5 or 6 lectures. It was very, very beneficial for the students because they are learning this in my astronomy class during this summer. So wish them the best and thank them for attending. For sure they will get 2 bonus points. So that's the most important thing for them, besides for sure the lecture. So hopefully, so every one of us has benefited from this. Thank you, Dr. Mubashir. Thank you, Mariam. Thank you, Anas. Thank you, Talafha. Thank you, Rayhan. Thank you, Selma. Thank you, myself, for this presentation, and hopefully we'll get to have more of these workshops in the future. So please, if you have any wish for any type of workshop in the future, so please let me know, and we'll manage to have one by next fall, and hopefully it will be more open than we are today. Everything is online, so we're getting a little bit sick of this one. So hopefully by next semester we will open up and people can come to the academy to visit us, to see the meteorite collation, and also to visit the research labs. So again, from the bottom of my heart, so thank you very much for presenting. Thank you very much for attending, and see you next time. Assalamu alaikum.
Thank you, Professor. Thank you very much.
Thank you.
Thank you, Dr. Ilyas. Thank you, Mariam. Thank you all. Thank you.
Thank you very much. We appreciate that.
Okay.